All right, so we're back with applications. So this one says, we need to find the dimensions of the rectangular corral split into two pins of the same size, producing the greatest possible enclosed area given 300 feet of fencing. All right, so what does that mean? Well, let's first draw that rectangle. And we're supposed to make two pins in it. So we're supposed to split it in two that are equal. All right, so we have that. So now if we wanted the area, greatest possible area enclosed, then what we have to do is we have to find, what x times y is equal to. Now, we don't know that. We just know that there's a total of 300 feet of fencing. So we need to find how much all these are. So if that's x, and that's x, and if that's y, that's y. So that's how much fencing we need to have. 1, 2, 3 x's plus 1, 2 y's. And that's supposed to be equal to 300 feet of fencing, okay? So that's how much fencing we have. So what can we do with that? Well, we could solve for one of the variables. Let's say we solve for y, okay? So let's go over here. So y is equal to, well, actually, that's 2y is equal to, so I'm gonna subtract 3x and then plus 300. Now I can divide by 2. So y is equal to negative 3 halves x plus 150, okay? So that is this part. So now I can say, okay, well, now I can find area because now I have y and I have x. And so area of, let's call it, let's say a, well, let's just say a equals x times y, okay? What we can do is we can substitute y into here, and it's in terms of x. So now a of x is equal to, well, we know it's x times y, which is that. And so that is going to give me my area enclosed, okay? Now what I need to do is start finding out what the pieces are. So what can I do? Well, if I multiply this out, that's going to be a negative 3 halves x squared plus 150x, okay? Now that looks to me like a quadratic. And with a quadratic, what can we do? Well, we know that this being negative, a is less than 0, so that means it's going to give me a max value, which is exactly what we want to do. We want to maximize that area. And so how are we going to do that? Well, we need to solve for h and k to kind of figure out that vertex, okay? So h is going to be equal to what? It's going to be a minus b. Well, b is 150, so net minus 150 over 2 times a, which is negative 3 halves. Okay. Now here the 2 cancels the 2, the positive and positive, and so 150 divided by 3, that's going to give me 50. Okay. Now 50 what? Well, it looks like it's going to be 50 feet. Okay, and that's going to be my 1 point on the vertex. Okay, that's going to be my x coordinate, and so I'll have, some 50 comma something. Now I need my k. Well, what is k? Well, k is going to be equal to, basically, now I have to plug in back into this function here. I'll have a negative 3 halves times 50 squared plus 150 times 50. And if I plug that in my calculator, I have negative 3 divided by 2 times 50 squared, and then plus 150 times 50. And I get 3750 is going to be my k, and so that's going to be 3750. Now think about that. What that's going to be? Again, that's going to be your in this case feet squared, because you took the feet here and squared it, and each one of these is a foot, and so this is feet squared. So when you have 50 feet here, you're going to end up with 50 feet squared. And so now what can we do? Well, that gives us the vertex. Well, that really doesn't help us super lot unless we plug it back into this formula or this formula. If we plug it into this formula, we can say, okay, well, y equals negative 3 halves times 50 plus 150. And so divide that's 25 times 3 is 75. So that looks like that's going to be 75 feet. So y is 75, x equals 50. And so, if we take 50 times 75, we get 3750. So that makes our area correct. So 50 times 75 is 3750, and that's feet squared, which is what we said it should be if we plugged in 50 into our equation. So now we've kind of solved this two ways. We've kind of solved it down and we got our value here, which give us the 50, but we had to plug it back into one of the original equations here to solve for the y value. Or we could have taken and plugged it into this and said, okay, 3750 equals 50 times x, or y, I mean, and then divide by 50 and we would have got 75 the same way. So we could have done it two ways. Like I said, we could have taken 3750 equals 50y, divide by 50, and y equals 75. And so we could have done it that way or done it the same way we did it here and got our 75. But in either case, what our values are is x equals 50 feet and y equals 75 feet based on the picture. Okay, and so that would maximize the amount of area enclosed by that amount of square feet of fencing. All right, what about the next one? Suppose that the price per unit in dollars of a cell phone production is modeled by P equals 45 minus 0.125x, where x is thousands of phones produced, and the revenue represented by thousands of dollars is R equals X times P. Now find the production level that will maximize revenue. So we want to maximize our R, okay? So what are we going to do? Well, we're going to take R equals X times P, which is this. Okay, so we have 45 plus or minus 0.0125x. Now we just distribute 45x minus 0.0125x squared. Now we write it as a normal function formula. So r of x equals negative 0.0125x squared plus 45x. And now it's in the form that we normally know. That's a parabolic structure because we have an x squared, it's quadratic. And so what we can do is we can find, and now when this is here, a is less than 0, so it's going to be a max. And so we need to find our h and our k. Okay, so h equals minus b, well, b is 45, over 2 times a, which is minus 0.0125. And so if we plug that into our calculator, negative 45 divided by 2 times 0.0125, that gives us 1,800. And that's 1,800 what? Thousands. All right, so we have that H equals 1,800,000 phones. It needs to be produced, and that's the production level that was going to maximize revenue. So that's the production level. And K, if we solve for K, that's going to give us the revenue. So K is going to be negative 0.0125 times the 18, where's my numbers going? 1,800 squared plus the 45 times 1,800. And then that's going to be, now the key thing is, do we really want it just 1,800 because it's 1,800,000? And so probably we should, thousands of dollars is going to be what's going to be our revenue too. So I think we can do it this way and we'll be fine. So let's do negative 0.0125 times 1,800 squared plus the 45 times 1,800, and that's 4,500 thousands. All right, because again, it's represented by thousands of dollars. And So we put the dollar sign there, but if we include it in our sentence, then we can get rid of the dollar sign there, and that would be fine as well. Okay, but they wanted the production level. The production level is going to be that value there, and we just went ahead and figured out what our actual revenue would be there, and so that's going to be, something. If they'd asked both of them, you could have, and you could represent both of them and have them both presented in your final answer. All right, so the next one says a ball is thrown in the air from the top of a building. Its height in meters above ground as a function of time is in seconds is given by this quadratic. How long does it take to reach the max height? Well, think about it. You're throwing a ball up. It's going to hit some peak, and then it's going to fall back down. And probably it's going to fall back a little bit further, because if you're throwing from a certain height, it's really going to be a little bit higher. But what we want really is we want that vertex. We want the HK. And what is h? Well, h is going to be time, and k is going to be our height. Okay, so that's because this is going to be time going this direction, and so we're going to be at some, t time, and this is going to give us some, I guess, k height. All right, so what do we know? Well, we have to find h and k. H equals the minus b, which is 24, over the 2 times b, which is 2 times negative 4.9. And if we plug that into our calculator, we get 24 divided by 2 times 4.9. We get 2.44897, blah, blah, blah. So we're going to say that's approximately 2.449 seconds. Okay, so that's how that works. So that was time. And our height, which is k, is going to be meters. So if we plug that in, that's a negative 4.9 times 2.449 squared plus 24 times 2.449, and then plus 8. And if we plug all that into our calculator, 0.9 times 2.449. And again, that's, based on, if we round to the 2.449, this is the value it's going to give us. So it didn't really say here as far as, how many decimal places, but that's going to give us approximately, again, 37.388, and that's going to be in meters. So it takes that long to reach that height. And again, it's just asked how long does it take, but I wanted to go ahead and go further and also tell you where that height is when you reach that time. All right, so let's stop there and we'll come back for more.